All right, new directions. I didn't realize that the title of these slides sounds like a recovery facility, but new directions it is. All right, statistics develops rapidly. There's a lot of misunderstanding about that. Some faculty members have said to me, oh, well, I mean, things never change in statistics. Once you know all the stuff, you're good, and that's the furthest possible thing from the truth. We'll talk about a few directions that all the nerds are talking about. Probability of less than 0.005 as a new standard. Bayes factor statistics instead of p-values. And using what's called Welch's adjustment as a default. So p of less than 0.005. So recently, a large team of researchers published a call to redefine statistical significance at 0.005. And, the Twitter world exploded over this, and there were counter papers all over the place. Their argument was that if you change to 0.005, that you get more reliable results. Their arguments were, for a variety of reasons, the false positive rate in psychology has been too high. You'll hear me rant about issues in open science and reproducibility that focus on what's called the replication crisis. Many studies have failed to replicate, and the reason is that 0.05 is not strong evidence. There's a lot of minor things that you can do to get there pretty easily. The Agent 005 proponents think that this would dramatically improve replication rates if we had to use this as a new standard. All right, Bayes factor. What is a Bayes factor? Bayes factors address the strength of evidence for the null versus the alternative hypothesis. Values of greater than 1 in the context of these analyses suggest greater support for the null compared to the alternative, but generally 2 to 6 is considered positive, more than 6 is considered strong evidence. Technically, these values, there's 2 different versions of these. The value that we'll look at is called BF10. That is giving you the evidence for the alternative hypothesis over the null hypothesis. BF01 is the null over the alternative, and we can see that we can easily go from one to the other. Here, for our data, we use the Bayes factor package. And you can see we just give it the formula, and then we have to tell it the name of the data file. And it gives us a value of 1.47. Then this is for the support for the null over, support for the alternative over the null. So technically, this is the likelihood of the alternative being true over the likelihood of the null being true, about 1.5 times more likely that the alternative hypothesis would be true. Now, in terms of the interpretation, this is the typical interpretation of BF10. If it's less than 0, it suggests that the null is stronger evidence. 0 to 3 is considered weak or anecdotal evidence. That's where we were. 3 to 10 is substantial. 10 to 30 is strong. 30 to 100 is very strong, and 100 plus is decisive evidence. If BF is less than 1, you can take 1 divided by the BF, and that is actually BF01, the likelihood of the null over the likelihood of the alternative. And then you can interpret that evidence up above. So even though our value was 1.5, and even though we were able to reject our null hypothesis, our value was only 1.5 for the Bayes factor, suggesting pretty weak evidence. Welch's adjustment, and this gets into some stuff that we'll talk about when we talk about assumptions of the t-test. Recent work had argued that Welch's t-test should be used as a default test. This test adjusts for unequal variances. It does so by changing the degrees of freedom or adjusting them downward. You can see our degrees of freedom here are adjusted slightly downward. They went from 103 to 101.6. And article by Lockins and others argues that you should just always use this. This should be the default. And it is the default actually in R. In order to run the Welch's test, you can use again, the t-test piece. you simply take out the var equal piece. And you can see we get roughly the same result. By decreasing the degrees of freedom, this will adjusts for inflation of alpha for when we have problems with unequal variances. Something we'll talk about when we get to assumptions.